This is Dr. Kraus, and I wanted to create a quick video. Some students in ME458 were asking me, we learned about feed-forward control, and they wanted to know if that was something they could incorporate in the ME450 final project with the Zumo robots. And so I wanted to make that an option to do whatever advanced controls things you can think of. But in order to, those are things that I can't support from the web interface. I can't just make different web pages for you to do whatever things you can dream up. So if you want to do that, you're going to have to edit the Python code yourself. It's actually object-oriented Python code, which might be just a little bit intimidated. I think once you learn a couple of things, it's really not that bad. So in order to do that, you're going to have to use something called VNC, which I think stands for Virtual Network Computing or something, to log into the desktop on the Raspberry Pi and then open IPython's NumPy interface and then run a test that way. And so I want to show you how to do that. First of all, on the course website under Final Projects, I've added a link here that helps you get the actual serial code that is currently running the actual tests. It's not the web interface, but it's what the web interface calls when it wants to run a test. So if you click on that, it will download the Python file for you that has all the code in it. We'll talk about that in just a second. And then I don't yet have this installed on the computers, but you'll need some kind of VNC viewer. Certainly there's one for Windows. And then it's going to ask you for the password that's specific to VNC. And that password is Lyapunov. I'll type it in here, but obviously you won't see it. But I want you to be able to see it. So it's L-Y-A-N-P, Lyapunov? No, that inspires your confidence, right? L-Y-A Lyapunov. So he's the famous, I have to actually look up my own. Yes, he's the famous nonlinear controls guy. L-Y-A-P-U-N-O-V. L-Y-A-P-U-N-O-V. All lowercase. That is the VNC password. And when you do that and hit OK, the first time it would probably give you some kind of warning about how this is not a secure thing or whatever. And then this always pops up, and I don't know why. Then if you click up here, so this is now the desktop of the Raspberry Pi. If you had it plugged into a monitor, this is what you would be seeing, but I'm obviously on my laptop doing this. And so then I still need to CD into here. And then if you want to be absolutely certain that you had the latest code, you should run git pull origin master. So that will include any updates that I've recently made. And then from here, you would just type NumPy, which is short for numerical Python, N-U-M-P-Y, NumPy. It is not NumPy. Nothing will frustrate me faster than you thinking you can mispronounce things just because you don't know how they're pronounced. It is NumPy. So then from there, I need to run that code, the Zumo serial code. Let me go over back to my main desktop, and I do have it open. And so it defines all these classes, which again we'll talk about in a minute, and then it specifically creates an instance, is what it's called. So my Zumo is an instance of the Zumo serial connection PID control class, and it's passing in some initial PID parameters. What this does when you call it in this way is there's an init __ I-N-I-T, init __ method of this class that gets called to create this instance. And so if we went to where's the PID control? There we go. So when I call the class and then I pass in the parameters, it calls this specific method and does these things and then returns the class. Returns the instance of the class. Sorry. And so if that's already starting to freak you out, let me say one thing. What you're going to do in your own version of this is to import Zumo serial and then create your own derived class. And if you look, for example, at the PD control, the PD control, so the P control defines a whole lot of stuff. Well, the PD control is really only this many lines of code. So all you're really doing is defining your own calc v method, which is the method that gets called inside the for loop every time you want to calculate the next velocity for the next pass through the for loop. And so the PD control method has its own init method because it needs to take in the parameters of the KD parameter, which the P control obviously doesn't need. And then it saves that. And so self, everywhere you see self, that's talking about the specific instance that we created. So down at the bottom of the code, I showed you that my Zumo equals this. Well, then every time you see self, that would mean my Zumo when this code is actually executed. And so we're saving the KD value. We're explicitly setting KI equal to 0. And then in our calc v function, so this function is being overridden, is what it's called. Overwritten? I think it's override or overwrite. That's interesting. I'm not sure. But all that means is that any methods that are defined by the P control class, this automatically inherits, and then the calc v method has been replaced with this code. Everything else that's in here, and there are many of them, like the run test method, the init vectors method, blah, 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 blah. Those all stay, but this one method, no, I can't get back to where I was, sorry. Oh, I was doing PD, that's right, because PID's got some other extra stuff in it. This one method is the only thing that's being overwritten. And so all you would have to do to derive your own class is to have this class, my class, and have it inherit from PID probably, and then define your own calc v function. So then, if you did that and you were ready to run a test, I now have this my Zumo instance, and just like in the web interface, the first thing I need to do is open the serial connection, and you'll notice it. So it's my Zumo dot open underscore serial parentheses, open and close parentheses, and then it returns that same message. If you don't see that message, then there's something wrong, just like on the web interface, and then also just like on the web interface. And I'm using the tab completion and the up arrow to get to some commands that have already been entered. I'm going to calibrate. And then if, for instance, I wanted to I wanted to ask what KD was, I could do that. I could also overwrite the KD value. And so now I've changed my KD. Here's my KP. And if, for instance, as I've talked about, if you wanted to set the minimum to, say, -200. So now it can go a little bit backwards when it needs to corner, but not full reverse. I'm just kind of making that up. And then I could run a test. And so the test is running. And then when the test stops, if I wanted to get the report, there's a get report that's what's used in the web interface. I'll show you that first. And that's more or less fine, but that returns HTML code, which maybe you can read, maybe you can't. It's not super easy to read. So I made a different version that was report NumPy. NumPy is kind of like IPython, but with NumPy, and the plotting library is already loaded. And so there's the report in a nicely printed form. So my score is 70.4-ish, and I've got an error score and a lap time, and my lap time is 6.36 seconds, which isn't bad. My total error looks to be 320,000-ish. So maybe that's better than some of you are doing. Maybe I shouldn't show you this many details, whatever. Yeah, and then if you also wanted to look at the plots, there is a method for that. And so figure 1 is the plot that you would see just on the website. It's just showing you the error versus time. But if you also wanted to look at, those are the voltages to the two different motors, so the left and the right motor, and then this is, the error is a weighted average of the sensor signals. Well, this is all of the raw sensor signals. I think there's 6 sensors. If you want to look at them, and this is an empty figure that shows up for no particular reason. I should get rid of that. Yeah, so those are my thoughts. Thanks.